oxygen demanding waste. Get rid of the organic waste before it goes to the Tennessee River. And they use bacteria to do it. Just like the bacteria would do it in the Tennessee River, you just put it straight in there. But we don't want it to happen there. We want it to happen in a tank on land where we can control it and all that stuff, right? And so that's what happens in a wastewater treatment plant. But anyway, I think one of y'all's is like on the, like if you're coming from Huntsville and you cross the Tennessee River Bridge and you take that first right, and is that the Beltline? Or
what's it called?
It goes around by where, you know, the river and 3M used to be over there in Monsanto.
I don't know what it's called.
Isn't that?
That's Highway 20 and then turn on.
Oh yeah, it's Highway 20. That's right. So there's a wastewater treatment plant over there on Highway 20 that you can smell sometimes. You go by it. But anyway, let me keep going. So this is showing you eutrophication, algal blooms. You can see, you know, all this is not supposed to be there, but you had a lot of excess nutrients going into the water. So inorganic plant nutrients from farms would be like nitrates and phosphates, the NP and K. Cause overgrowth valves, release the pollution of solid oxygen, death of fish, sources, runoff from fertilizers and manure. This, they love to ask questions about also. I know, we're getting tired, right? We can do this, we can do this, we can do this, we can do this. All right. So, an oxygen sag curve, right?
Sag.
So, all right. If you ever see capital D, capital O, it's dissolved oxygen. That's how much O2 is dissolved in the water, right? So that's the blue line. It's usually measured in parts per million, right? Same thing as milligrams per liter or micrograms per milliliter, whatever. Y'all got to know what BOD is. Y'all got to know what BOD is. Anybody know what BOD is? Y'all talked about it yet? All right, it is the biochemical oxygen demand. So really, it's talking about, is there bacteria that are going to be eating a bunch of crap, dead algae or sewage, that's going to place a demand on the oxygen? That's what BOD is. So if you have eutrophication going on, or let's say that you have a big rain event, and guess what, guys? All pipes leak. All pipes, whether it's drinking water or wastewater. So think about this. This is kind of cool. Every drain in this building at Decatur High School, in your house, and all these businesses, and all the hospitals, if it's got a drain, it's going to a pipe below the building, and then they all converge together. Then they all run out to the street where it joins a bigger pipe that all the other houses and businesses have dumped into. And all those converge, and it goes to a great big pipe that'll go to Decatur's sewage treatment plant. So on the way, you're going to have leaks, right? But it's under negative pressure for sewage. Positive pressure for drinking water, negative for sewage, which is both a good thing, because if it rains, you know, and it gets down into the water table or whatever where those pipes are, if you're going to have a leak, you would rather rainwater go into the sewage pipe rather than sewage come out of the pipe, right? But, I mean, that is better. However, if you ask anybody that works at these sewage treatment plants, when it rains, you always...
How many of you went to Leon Sheffield? Okay,
you know,
it's across the street from the sewage plant.
Oh.
So these kids in elementary school smelled the smell,
Every day.
and then here's what they tell me: you get used to it. I don't want to get used to it. I don't want to get used to it. I sent my kids there though. Sure did.
some things in life you just have to stand for. You just don't. All right.
Right.
I'm sorry to interrupt. We want to give away a $10 Amazon gift card.
All right.
Just thank you for being here. So we have. How many
Did
on the
everybody
list?
sign in?
Everybody
Even if
signed.
you came late, Lawson, were you able to put your name on here?
I did.
Okay.
That's a very small.
How many names we got?
We have 30 children.
30. Random number generator. Number 19.
belongs to Brady Barnes. It's going to get him a book on Amazon.
Send all their Amazon gift cards. All I need you to do is
I want it.
sign your name.
I know, I did too. I did too.
I'm into.
Where do you?
Should have put my name on all the
I
time.
honestly, I need that. I'm trying to order a bowl from Amazon.
A ball.
Bowl, look at this bowl. 22.
I was 21.
You were 21.
Boston, I came.
Jacob Rogers was 20.
Look at this bowl.
It's just, never forget,
You just scoop this in.
everyone else is still a winner
Have it on there.
because you got a greasy biscuit and a lukewarm bottle of water.
I saw that last night.
You can feel
I don't
it.
feel that.
Move closer.
We can't tell if it's intimidating.
You can see it.
I did!
That's,
Slide it into the milk.
there's some good calculus happening.
I like
I can
some.
nerd out.
You do?
I love
Okay.
I like sauce.
Wait, I want to see.
All right, so stop hanging out. So the biological, our textbook calls it biochemical. I like biological better because usually it's the bacteria, life, that's causing this oxygen demand. So, okay, so here's the thing. BOD is in the red, right? Well, here's our sewage pipe. It's flowing to the right. So above the point source pollution, you've got normal clean water organisms, trout, perch, bass, mayflies, stoneflies. Those are all things that indicate there's healthy water. Notice that the dissolved oxygen is way up here at 8 parts per million. That's really good. And that's because there's low BOD. There's low demand for oxygen. But sewage is food for bacteria. And so all of a sudden there's lots of food, so you see bacteria start eating up that sewage. That increases the demand for oxygen. They're going to consume the oxygen. So BOD and DO are inversely related. If BOD goes up, the DO will go down. And this is the DO dropping. Now, different organisms have different requirements for oxygen levels. So you see a sudden change in the species here. I don't know if you like to fish, but you know it's fun to catch you know, bass or you know things like that, trout, whatever. Not that much trout here, but there's some rainbow. No, what is it? No. Anyway, and then all you can find is like gar or carp and leeches and things that can tolerate low oxygen. You don't find these guys anymore. They're gone. But eventually, in a flowing system, it dilutes out, the bacteria have eaten up the sewage, so as you go further and further downstream, there's less food for the bacteria, so the BOD goes back down, and the DO will come back up, and that's the sag curve. It'll sag down and then curve back up. And then you may or may not have a return of these guys that were up above the point source. So, y'all do need to know point and non-point sources of water pollution. You need to know what BOD versus DO is. Eutrophication, you got to know. And what else? Oh, here's another thing. So we talked about acid rain, but we didn't really talk about what it can do. So do y'all know what leaching out means? What is that?
A body of
It can pull things out and it carries it with it. So like you can have a landfill, and if water infiltrates into the ground and then percolates through, it can pick up bad stuff that we threw away that shouldn't have. We're all guilty of, including me. And then it can get it into the groundwater, right? Because it leaches it out and carries the bad stuff with it. Well, here's the thing. Acidic or acid rain has a more powerful leaching effect than normal rainwater. So it can leach out heavy metals much more efficiently, or much worse, I guess I should say, than normal rainwater can. Another thing that rainwater or acid rain can do is that it can acidify the soil. And if you acidify the soil, you can kill the roots of the trees. If you kill the roots of the trees, then the tree dies. And then all of a sudden you got sedimentation because nothing's holding the topsoil in place. And also you're leaching out heavy metals that are going to run off into the water. So now you got heavy metal contamination. And for some reason aluminum gets leached out. You know, these are all naturally occurring things. But you leach them out and aluminum coats the gills of fish and they can't breathe, you know. So there's all kinds of weird things that can happen. But anyway, what else? Let's go back to the beginning and see how well we did. All right, if wastewater treatment plant effluent that contains nitrates and phosphates is allowed to flow into a body of water, which of the following may result? C, eutrophication. Right. Woo-hoo. Eutrophication. Which of the following is the usual cause of cultural eutrophication in surface waters of both developed and developing countries? Well, first of all, let me say that eutrophication, when I'm guilty of doing this in class, when I really mean anthropogenic or cultural eutrophication or eutrophication caused by man, I usually just say eutrophication. But eutrophication is a normally occurring thing. We have deciduous leaves that dump on the ground every fall. Well, that's organic matter, and a lot of that will end up in the river. That's normal eutrophication. So cultural is talking about caused by man, anthropogenic. So they're found, which of the following is the usual cause of cultural eutrophication in surface waters of both developed and developing countries? Runoff of nitrate compounds into bodies of water. Only 53% got that right that year. All right, the presence of fecal coliform bacteria in a sample of river water suggests which of the following? The water is contaminated with animal waste, that's right. Could be human, could be cattle, could be pigs. All right? All right, so, acid, oh, by the way, I'm a firm believer in passing all compliments. So we have a new A+ College Ready, that's the people that run this program, that is running things. Dr. Matt Dean, he's here today, he's a really cool guy. Did it time go? We have to. Okay.
Oh, that's that.
Where you headed?
Basketball scrimmages.
All right.
They start.
Hi,
I'm part of
JB.
the basketball team.
No,
All right. Totally forgot what I was saying.
compliments.
Oh yeah, compliments. Yeah, you want to hear everybody wants to hear compliments. So Dr. Dean, I was standing outside talking to him at break, and he said, all the schools that are in the cohort this year, this is the best group he's seen.
Wow.
That's good. That's good. And I said, yeah, y'all are good. Y'all never know how you compare because y'all don't see the others, but I do, and y'all are good. Anyway, so acid rain is associated with which of the following? Burning of fossil fuels. I'm surprised that wasn't higher, but it's mainly coal burning, putting sulfur oxides and nitrogen oxides from gasoline. Which of the following would be the strongest evidence in support of a scientist's contention that a local area was experiencing acid deposition? This was one of the more missed questions because there's a distractor on there that people will often mistakenly answer. So remember how I said you can have a DO drop overnight and it causes fish kills? That's from the BOD going up and the dissolved oxygen crash. And then the next day you'll see fish covering the surface of the water, floating belly up. But you don't see that. Water becomes acidified slowly over time. And so it's going to be an increase in the concentrations of soluble heavy metals in local pond. So y'all may have said A, you may have said D, and this gets so many students, including myself. pH, we all know what pH is, you know, is it acidic or not? But when you see this, a long-term increase in the pH of a local pond, so many people are guilty of going, oh, that means it's getting acidic. But what happens if the pH rises? It's getting basic. And we forget that. You know, we associate pH with acidity so much that we think a rising pH, we're like, oh yeah, it's going to be acidified. No, if it dropped, it would be acidic. But it's going to start leaching out those heavy metals because acidic rain can leach out more. Look, 11%. I guarantee you they either put A or D. Okay, this is stuff that we've already talked about. Water-soluble inorganic chemicals, blah, 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 affect water. It can cause liver, kidneys, disease, skin cancer, nervous disorders. All right, compared to a coal-fired power plant that produces the same amount of energy. Oh, I didn't talk about nuclear. Y'all may have y'all talked about energy yet? Power plants? So, I should have said this already. So we all know that, yeah, there's radioactivity, possibly. Y'all remember Fukushima in Japan, and worse than that was Chernobyl. We had a little girl graduate last year from Bob Jones that her hands were at her elbows. And she was adopted by a couple that lives in Madison. But she was from Chernobyl. And there were a ton of kids that were dropped off on the doorsteps of fire departments and hospitals and orphanages because the parents either didn't know what to do with them, how to take care of them, or they just didn't want them. But there were a lot of physical deformities and mental retardation and all that stuff from that heavy exposure. Chernobyl was the worst of the accidents so far. I was in high school when it happened, and there was lingering radioactivity. But anyway, I remember to this day. Let me tell you a little interesting story. So I was in high school. It was in the late 80s, and I forgot which country was the first one to say, hey, we're picking up unusually high levels of radiation. Did y'all have a leak at one of your power plants? No, wasn't us. Everybody started talking. And at that time, it wasn't Russia, it was the Soviet Union, right? USSR. And, so they sent word to Moscow. Hey, what's up? Y'all got something going on? Y'all tested some nuclear weapons over there? What's going on? They don't know what you're talking about. And then, they kept collecting. So they didn't know for sure. They kept collecting data. So the highest counts were like in a ring around the Soviet Union, and then it got lower as you went away from. So the world's leaders were like, we know you did something. Do you need any help? And they were like, well, we had a small accident at our Chernobyl nuclear power plant. And yeah, we might could use some help. And they had a big fire. All the backup safety things failed, and they had to build a dome over it. They had to evacuate everybody out overnight. I mean, it was, and I don't know if y'all remember a book, and they made a short series on TV called A World with No People or something like that. And it talked about if suddenly all the humans disappeared for whatever reason, what would happen in 10 years, what would happen in 100 years, what would happen in 500 years, dams start breaking and all this other stuff. It was really neat. Well, they based that on Chernobyl because that's the only place that we have where people were suddenly removed. And they went there and investigated, and it was really neat because you would see like kitchen tables with food that was, of course, rotten or whatever on the plate still, and little baby carriages with dolls in it and stuff, and not babies, but anyway, it was really, really, really strange. But I remember that. Anyway. That's not the biggest day-to-day problem with nuclear power. Does anybody know what it is on a day-to-day as far as pollution goes? So you always see a coal-burning power plant and a nuclear power plant next to a big body of water. It's so that they can cool down the steam. Because, one of the things that all these things have in common, like even a dam that's hydroelectric, or coal burning, or nuclear, or if you're burning trash, you've got to somehow spin a turbine. And that turbine, when it spins, there's a rod hooked up to it, and that rod spins when the turbine spins. And the rod is going inside a generator, and on the end of that rod inside the generator is a magnet. And it's surrounded by a coil of wire. And when you spin a magnet inside a coil of wire, you generate a flow of electrons, and that's how you get your electricity. So what coal burning and burning trash and nuclear do is they generate enough heat to boil water to generate steam, and it's only allowed to go in one place, and that's through a pipe. So as the water expands, when it becomes a gas, it moves it through a turbine, right? Well, then they want to reuse that steam, so they have to cool it back down. And so they run cool water around it, and that the heat's transferred to the cool water from the river or the ocean, and then that steam recondenses into water, and then you can boil it again. But now you got this warm water, and that's going to go back into the Tennessee River, like TVA, Browns Ferry Nuclear Power Plant. When I was y'all's age, not y'all's age, when I was in elementary school in the 70s, it was the world's largest nuclear power plant. It had 3 reactors, still does. It's not the largest anymore. But, you know, if you put, here's the big idea I'm trying to get to, right? Long story short, too late, right? Warm water cannot hold as much oxygen as cold water. So again, you have a problem with oxygen levels. It's not living things using it, it's just the fact that warm water can't hold gases, including oxygen, as well as warm water can. So they try to cool the water back down before it goes into the river, but they can never quite get it back. Y'all know, I used to think when I was a kid that these were the reactors, but y'all have seen these big, tall looking buildings. They have them at coal burning power plants, they have them at Browns Ferry. Those are the cooling towers. And they're trying to get the water back down so the heat will go into the atmosphere. The water cools down, then it goes back into the river, but it's never, I've spoken to people that work there, it's never quite as cool as the river water. They can't get it quite all the way back down. And that means that there's less oxygen around those plants. So that's called thermal pollution. That's the most common day-to-day pollution from a nuclear power plant. There's really not a lot of air pollution, right? You're not burning coal or anything. You're just splitting atoms. Now, you do generate radioactive waste. And where is most of the radioactive waste stored to this day in the U.S. anyway? On site, because we don't know what to do with it. Scientists say that probably the best place to store all of our radioactive waste is where in the U.S.? It's in Arizona or Nevada. One of the two. It's in a mountain, Yucca Mountain. You ever heard of Yucca Mountain? But of course, everybody in that state around that area is like, heck no, we don't want everybody's radioactive waste coming here, you know? And so it's still stored on site. Now they put it in vaults and concrete and sink it in water and blah, blah, blah. We had a guy come talk to some of our students a couple of weeks ago that works at TVA, and he said what's the dome? There's a dome that goes over the reactor, the containment dome. Supposedly it can withstand over 300 mile per hour tornadoes, you know, things like that. It can withstand a missile, you know. He's just like safe. And, you know, in the back of my mind, I was thinking, tell that to people at Chernobyl or Fukushima. But anyway, but really there's no radioactive waste unless there's an accident. But there is a daily thermal pollution issue. And you'll know, like if we were to take 2 Coke cans, open up both, leave one on the kitchen counter, put one in the refrigerator, then came back 10 hours later and took a sip of each, which one's going to taste flat? Or the one that you left out, right? Because most Coke is mostly water, right? And so that CO2 is what gives it that nice burn kind of, you know, that flavor. And so all that CO2 left the Coke, right? Because warm water can't hold on to gases like CO2 and O2 as cold water can. Okay, this is thermal. We've already talked about this. Which of the following, okay, I'm going to skip over here to this picture real quick. So this is a diagram that's probably in your environmental science textbook. This is a general scheme or drawing. Most sewage treatment plants are a little bit different than this, but there's primary and secondary. You will see questions, plural, on the AP exam about this. So primary treatment is a physical treatment. Secondary treatment is largely known as a biological treatment. This is where you are going to, when the water first comes in, it's not as dirty as you think it would be. I mean, it's pretty dirty, but it's, people think that there's going to be like floating feces, getting trapped. It's usually broken down by then, by the time it gets to the treatment plant. But there may be large items that got flushed that shouldn't be flushed, When I had I shouldn't say this, but when I was at Auburn, I had a friend that was in civil engineering, and they had to take a whole course on water treatment, both drinking water and wastewater and all that stuff. And they were about to go on a field trip, and the professor kept saying, well, on the condom tampon screen, he would just always say that. And they're all like, that's weird that he keeps saying that. And then they went on a field trip, and then they saw the screen, and it was covered in, guess what? Condom and tampons. Those are not supposed to go down the toilet, by the way. So anyway, so you get the large things that are too large to pass through the screen, right? And then you'll come to some type of settling tank. Now, you'll hear the word flock, right? Or flocculation. So you have to allow the water a certain amount of time to stand so that the heavy particles can settle out to the bottom. And that's going to form sludge that you'll have to do something with. In Madison, we take it and dry it out and then use it as fertilizer on a sod farm in Madison County. I'm sure y'all's go somewhere. But anyway, it can't be put on a crop that's directly consumed by humans. You can, or at least the one in Madison anyway, you can feed it, you can use it to fertilize corn, and the corn can be fed to cows that humans can eat, but you have to have a 1 trophic level buffer. But it depends on the treatment. You can get it to a higher temperature when you're drying this out and expose it to the sun longer, and then you can put it on crops that can be directly consumed by humans. But anyway, this is good organic matter. This is good fertilizer. Anyway, so that's all physical stuff. Allowing things to settle out or screen, capturing the stuff, that's a physical treatment. This is where you're going to bubble air, although Decatur does not, I don't think. If you bubble air up through it, it's an aeration tank, and you're promoting aerobic bacteria. And they're going to break down, this is where the whole purpose of the plant is mainly right here. You want the bacteria to break down the organic matter, okay, because that's a lot of BOD. Because if it went straight into Tennessee, the bacteria would break it down, the DO would plummet. So we want the BOD to go up in this tank on land, right? And then you may have another settling tank. And then finally is the disinfection. And you can either, Madison City uses gigantic ultraviolet bulbs, so water has to move in between these big UV bulbs. Some places will ozonate, right? Use ozone gas because it's such a strong oxidizing agent. And then some people add chlorine. Now, and then it goes into the Tennessee River. Decatur, at least at one of its plants, y'all use anaerobic digesters. They don't bubble air up, and so you have anaerobic bacteria. Now, it's good and bad because anaerobic bacteria, instead of producing carbon dioxide, it produces methane, right? There's no oxygen, so there's no O for CO2. It's CH3 or CH4. And it smells bad, right? However, that's combustible. So they capture that gas coming off, use it to boil water because they burn it, and then turn a turbine. So they produce their own electricity. That's pretty cool. Of course, there's always that chance of boom, right? So anyway, now you have sludge you have to do something with. If you can use it as fertilizer, or it can go to a landfill. If it goes to a landfill, then you may have shortened the lifespan of that landfill because it fills up faster. And landfills are really hard to site, to find a place where to put it. Okay, so that's what I said, all that stuff. Let's talk about this. Okay, so Which of the following is an effective alternative to chlorine for disinfecting wastewater in a municipal treatment plant? We just said one of them. Ozone. 11% got that correct that year. Which of the following components of a wastewater treatment plant is designed to facilitate the decomposition of organic material by aerobic microorganisms? I didn't call it this. I should have. Anybody want to guess? Yeah, activated means you got active bacteria breaking down. All right. The FRQ for this one is the one, I don't know how your teacher does it, this is the way I do my FRQs. So, they release the FRQs every year after 48 hours after the AP exam. They're all online for anybody that's interested. You can go look them up. I go through and I went back every year since the beginning of this course, and for each unit, like water, I'll pull out the questions I can find about water, and I put them in a packet. I give it to them a week ahead of the test, and I say, here they are, you answer them for homework. It'd be best if you try to answer them on your own, and then go online and see how good you did, and fill in, what you didn't know. Hand that in as homework on the day of the test, and then we draw a number out of the hat. Whichever one they draw is the one they have to answer from memory. So there should be no surprises. But that's how we do FRQs in my classroom. But when it comes to this unit, this sewage treatment is such a commonly asked question that I put all the same number in the hat. They don't know that, so that I know they're going to get the sewage treatment question, because that's the one I really want them to answer. I have been busted before, but anyway. They never trusted me. After that, it was like, let's see the other numbers, Mr. Johnson. But, all right, so let's answer this. It's I bet y'all can answer most of these now. I always use the town of Fremont, I don't know why. Hey, by the way, another little thing to remember. Y'all know what a municipality means? It's a city, right? Do y'all know what per capita means? Per person. Per person. Can we do that? Holy crap. Yeah. Are we about to get out? Holy crap. Okay.
Holy crap.
No pun intended.
Oh, Lord. I got to go wait.
Totally not bad. All right. What if we just go over it? You want to do that?
Yes.
Okay, so